Hello friends, welcome to educators.com. I am Preeti Rathi. In last video, we have seen functions and pointers and passing parameter by reference. Now in this video, we'll discuss about arrays. The topics which we are going to cover are arrays in C, one-dimensional array, then declaration of array, initialization of one-dimensional array, then two-dimensional array and initialization of two-dimensional array. Now what is array and why we need it? Suppose we want to have multiple variables of same data type. For example, we want to store the marks of student, but there are 10 subjects whose marks we want to store. So instead of giving different variable names, that is x, y, z or marks 1, marks 2, something like this, we can use arrays. So arrays are derived data types because we declare array the way we want. Arrays are collection of homogeneous data that is belong to the same data type. So if I want mark of student to be stored, I can create an array of 10 element which will hold integer type of data, and then using the index of array easily we can access and manipulate the values. So array elements can be accessed by its position in the array called as index. Values in an array are identified using array name with subscript, that is subscripted variable. Then the array is fixed size collection of element. We cannot resize the array. The types of array are one-dimensional array, two-dimensional array, and we can have three-dimensional array, which is also called as multi-dimensional array. Now one-dimensional array, it is a collection of variables given one variable name using only one subscript, and such a variable is called as single subscripted variable or one-dimensional array. We can declare it using data type, array name and size of it in bracket. Now data type can be any valid data type like integer, float, character. Then the array can hold elements of that type. Array name is a valid identifier. Size, it is a maximum number of elements that can be stored in array. So we have to provide the size at the time of declaration itself, and after that it cannot be modified. It cannot be increased or decreased. So we can say that arrays are fixed size collection. Now we can even initialize array at the time of declaration using initialization string. So at that time we can give value this way, that is integer marks 5, and directly the values we can initialize this way. Now array index always starts from 0 till length minus 1. So this 55 will be in marks 0, then at the marks 1 it will be 63, for marks 2 it will be 67, marks 3 78, and marks 4 means at the fourth index we will have 59. If the array is not initialized, then it holds garbage value at runtime. Now we can even have two-dimensional array. So two-dimensional arrays are also called as matrix. Now here is a sample program that stores roll number and marks obtained by a student side by side in a matrix. We have declared an array which is a two-dimensional array which has 4 rows and 2 columns. Then we are having a for loop which is running for the number of rows from 0 till 3, and we are asking for the roll number and marks, which will store in the first row 0th element, then first row first element. So roll number will go in a 0th element and marks will go in a first element, then second row and then third row. Then all these 3 rows we can display using another for loop. This way we can use two-dimensional array. Now we can have initialization of two-dimensional array also. Now when we go for initialization, we can use this initialization string in this pattern or directly also. So the first element will go in a 0 0, then 0 1, then 1 0. Like this the elements will be stored. Now here it is important to remember that while initializing a two-dimensional array, it is necessary to mention the second dimension, that is a column dimension, whereas the first dimension means row is optional, because by reading this column number it can decide how many rows will be required over there. So I can have both declared, that is 2 by 3's array, or I can just give column number and skip the row. But column numbers are mandatory, otherwise compiler will not be able to decide how many rows it should have. So this declaration where column is skipped is not valid. So these two declarations are not valid. So this way we can have initialization of two-dimensional array. Now we will check out this concept practically. Now in this example again we are having hash include stdio.h and conio.h. These header files we have included for standard function. Main is the entry point of our application, then clr scr is to clear the screen and getch is to retain the screen. Now here I will declare the array. Suppose we have a requirement to store the marks of 5 subjects and then to calculate its sum and average. So I'll have array say marks for 5 subject. So this integer decides what kind of data marks array will store. So it will be now integer and it will hold 5 elements. This size is mandatory here. If I omit it and if I try to compile this, so we'll get compile time error. So the size is mandatory at the time of declaration itself, and then we cannot modify it. So it is a fixed size array. Now we'll have a for loop. We'll declare a counter for that. This counter will initialize in the loop. We'll have less than 5 because we have seen that array index starts with 0 till length minus 1. Then we have I++. Now here I'll ask end user to enter the marks. Now we will read the value in the array element using ampersand marks of I. So initially I is 0, then 1, then 2, like this in the for loop it will go ahead. So this way we'll read the data in the array. Now we can have another for loop to display the data and calculate sum. So again I'll have I equal to 0, reinitialization, I is less than 5 and I++. Now to hold the value of sum, we'll declare one more variable, that is sum. Now this sum should be initialized to 0, otherwise by default it will hold garbage value. So we can have sum equal to sum plus whatever value we have in marks of I, and then we'll display that marks also, that is marks of %d element is %d. Say I element and the marks is marks of I. So we will display the element position as well as the actual marks. And after calculating this sum, suppose we want average also to be calculated and display both, then I can have another variable for average. That is, I can go for float average, initialize it to 0. Then here we can calculate it, that is average equal to sum divided by 5 subject, and then we'll have printf sum equal to %d and average equal to %f. Then we'll display sum and average. So now in this example we are initially asking for 5 marks of 5 subject in one loop. So here we'll enter all the values and store it. Then we have another for loop which will read value and add it in the sum variable. Then next we will display the element also. Then we calculate average, and then we are displaying sum as well as average. So here we can say sum, or we can say addition of all marks, and this is average of marks. Now here we can start it with the \n to display the output on new line. If I'll execute this, enter marks, it's asking for marks. Now 5 marks I have to display here. Then we got marks of 0 element is 60, then 70, 80, 50, 40, whatever I have entered. Then addition is calculated and then average is found. So average is 60 and addition is 300. So this way we can use the array, means using array we can handle multiple elements of same data type easily. Now in this thing, one more thing I'll add, that array elements always gets the continuous memory. Means marks of 0, then the memory of marks of 1 will start, then of 2, then of 3, like this it will get the continuous memory. So to cross verify that, I'll display the address also. We will display with one printf here, address of %d element is %u. Now ith element, and for address I'll display ampersand marks of I. Now if I'll execute this, I'll enter few marks here. Five marks it will be asking. And now if we'll check out this address, so you can see that this is 16. So integer requires 2 bytes. Next is 18. Then next is 20, 22, 24, like this. It shows that elements are in a continuous memory. Array elements are always in a continuous memory. So this way we can use one-dimensional array. Now this one-dimensional array we can even initialize with the initialization string. Suppose I don't want to ask the value from end user, then I'll just comment this for loop where I'm asking value, and I'll go for initialization. So here when we have declared it, we will initialize this array with some values in the bracket. Suppose it is 60, 45, 68, something like this. 5 values we have to enter. So this will again go to 0, 1, 2, 3 and 4. Now if I'll execute this, so we'll get all the values displayed here, 60, 45, 68, 70, 60, and relevant addresses are also continuous. Addition is calculated and average is also calculated. So this way we can use initialization string. Now next we'll check out two-dimensional array. Now the two-dimensional array can be initialized this way, that is integer whatever is array. Suppose I'll give the name of array as ARR, where I want two-dimensional values to be stored here. Now we have to give some size here. So suppose I have 4 rows and 3 columns. So the first dimension is a rows and second is column. Now to take the value for this two-dimensional array, we can use nesting of the for loop. That the outer for loop will work for number of rows. So I'll take a counter as R, and for column I'll take counter as C. Now this R I'll initialize to 0. Then we'll have R is less than 4 and then R plus plus. Now if I have for the column, then C equal to 0, then C is less than 3 and C plus plus. Now inside this we can ask for the value, that is printf interval, then read the value. So for that we'll have scanf and we'll read the value using ARR of R and C here. So in R we are holding the number of row and in C we are holding number of column. This way we can read it. Now we can use a separate for loop for display or having any computation, or even we can display it in the same for loop. Say if I'll have another for loop here, so I'll end this loop here, then again I'll create another for loop where I'll have the same thing. R is equal to 0, R is less than 4 and R plus plus. Then we'll have inner loop over here which will be initialized to 0, C is less than 3 and C plus plus. Now if suppose I want to just display the values, then I can go for printf. Now we have row number as 0, that is present in a %d, then column is again %d and value, and the value is again %d. So here first for row I'll have R, then C will go in a column, and then actual value, that will be ARR of R and C. So here in the first %d R's value will go, in second %d C's value will go, and in %d of value this value will go, and we'll end it over here. So now using nesting of the for loop, we are reading and writing values into the array. If I'll execute this now, I'll just give the simple values. (11) and then 12. So you can see all values are now. See, I haven't given this ampersand over here, so we were getting the junk value, because whenever we use scanf, always we have to give the address of a particular variable. Now if I'll execute this, so we'll get the proper values. So these are the row number and column number. First the row is first only, column is changed from 0, 1, 2. Row is first 1, column is 0, 1, 2, row is 2. Like this the values will be given, and these are the actual values. Now even though two-dimensional array we visualize as a matrix, but still it gets a continuous memory. If we want to check out that, we can just give address over here, that is ampersand of ARR of R and C, and that will display here address as %u. Now if I'll execute this, so you can see again the address are in a continuous way. 02, 04, 06, 08 means integer takes 2 bytes, so every next address is after 2 bytes. So this way the array gets the continuous memory. Now just like one dimensional array, we can have initialization of two dimensional array also. For that purpose, I'll again comment this first for loop where I am reading the value from end user, and I'll initialize the value at this level. Now here directly I can initialize the values. Like this 12 values I can initialize here. Now if I'll execute it, so values are displayed and the relevant addresses are given. Now suppose I have given size as 4 by 3, so I expect 12 values, and suppose I have given bit less values, 2 values are less. So in that case it will not give any error, but whatever values are left, it will fill them with the 0. It will remove the garbage value and it will fill it with the 0. So you can see here these two values are 0. So this way we can use initialization of array. Suppose sometime we don't have the element there, but still we are trying to access it, or we are going out of bound, that we have 3 columns and if I have given C less than equal to, so I am going out of bound. So in that case compiler will not give any error, but it will give some garbage value. So now in this case when the values are not available, it will just give some garbage value. So we have to monitor it, that what is the index of row and column. Now here we have discussed about arrays, what is the use of array, what is one dimensional and two dimensional array, how to declare and initialize them. Now in the next tutorial we will see three-dimensional array and will relate pointers and arrays. Thank you.